Here we have used linear regression to model the relationship between egg yolks in a cake and the amount of cholesterol in the first part. And now we're on to part C. It says, what is the y-intercept of the regression line? So our regression line here is y1 equals 28.4x plus 8.0. So the y-intercept is going to be 8.0. And so that's the initial amount of cholesterol, right? Our y-intercept is the initial value that we're starting at. So this is the initial amount of cholesterol in a cake. Is 8.0 milligrams. So the y-intercept gives you initial value. The slope gave us the output over the input, the amount that we were adding with each egg that we put into the cake. So we're going to use this equation called y1 that we found in the first part to predict the cholesterol in a cake with 12 egg yolks. So I'm going to plug into my y1 equation from above. So I'm going to do y1 is going to be 28.4. And I'm going to replace my x, the number of egg yolks, with a 12 in parentheses, plus 8.0. So I'll just grab my calculator and plug in 28.4 times 12 plus 8 and find the amount of milligrams in the cake is 348.8 milligrams of cholesterol. We plug in the number of egg yolks and we get out the milligrams of cholesterol. The next step says find the equation of a line that passes through 2 points that represent data for 6 yolks and 7 yolks. So we use linear regression to start this problem, but now we're going to not use linear regression. We're going to use 2 points to find the equation of a line. So looking at the chart, I need those x values and y values. So I'm looking at 6 and 7. So we have the point 6, 162, and the point 7, 195. So we're going to bring these points down with us and find the equation between them. So the first part of finding a linear equation is to find the slope. y2 minus y1 over x2 minus x1. So I'll call this x1 y1 and x2 y2 so that we can plug into this equation. So y2 is 195 minus y1 is 162 over, we have x2 is 7 minus x1 is 6. And I'm just using these because that's what the problem asked me to. It said look between 6 and 7 egg yolks. So I'm going to grab my calculator and just subtract the top. 195 minus 162 is 33. So 33 milligrams of cholesterol is the difference there between 7 minus 6 is 1 egg yolk. So we get 33 as our slope. Our second step is to find b. So I'm going to write y equals mx plus b and sub in one of these points. So it doesn't matter which point we choose. Maybe I'll choose this point here. So I'm going to replace y with a 195. I'm going to replace m with 33, what we just found in the first part. X of this point is 7 plus b. And you can use either point and you should get the same answer. It doesn't matter. I just randomly chose that 0.7, 195. So first thing, 33 times 7 is 231. Plus b is our 195. And then we just need to subtract to get b by itself. So subtract 231 from both sides. So 195 minus 231 is negative 36 for our B. So we have our M and our B, and our last step is to write our equation. Y equals 33x minus 36. And just be careful, we are asked to call this equation Y2, so I'm going to label it as Y2 equals 33x minus 36. So based on this equation, Y2, that we just found, how much cholesterol is in a cake with 3 yolks? Round our answer to the nearest tenths, and then we're going to compare it to what is actually in the table. So we are going to plug in 3 for our x. Figure out how many milligrams of cholesterol there are. So we're going to do Y2 equals 33, and I'm going to replace the x with a 3 in parentheses, minus 36. So 33 times 3 minus 36 is going to give us 62 milligrams of cholesterol. And let's compare it to the data collected on the table. You just have to look above here. So according to this table, a cake with 3 egg yolks should have 73 milligrams of cholesterol. So we have 3, 73. So we would say that according to the table, 3 egg yolks yields 73 milligrams of cholesterol. Again, looking back, I'm just looking at the table here. 3 has 73 milligrams of cholesterol. How does that compare to our answer, which is, we guess 62, 9 milligrams higher than our estimation using Y2. So Y2 didn't give us a perfect answer. It was 9 milligrams less than what was on the table, or what was on the table was 9 milligrams higher than what we found using Y2. So not perfect, but gives us a guess without needing a graphing calculator to do regression for us.